Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our series titled Happily Ever After. In this episode, I will show how you can often extend the range of a machine without a rebuild. This will require both mechanical and control engineering skills, as well as a bit of homework. Before we define what extending your range to 110% means, we must first define percent, as we will do in this slide, and then what 100% means, as we will do in the next slide. There are very few proper units that are unitless. One web handling example is strain or stretch, which could be in units of inches per inch or meters per meter. Occasionally, you will see those values expressed as a percent. However, when we see percent on our machines, it is seldom an engineering unit that can be independently calibrated, such as we can and should do for both dancers and nip rollers, when the machine builder has not done that for us. Not only is percent not an engineering unit, it isn't quite even a machine unit. Examples of a machine unit are air pressure on the nip loading cylinder. We could and should calibrate those systems in proper engineering units, as just mentioned. Instead, percent is something quite different. I'm not even sure it has a proper name. To say that percent is a completely arbitrary unit that few understand is often closest to the truth. What I mean is that if we reran history, a different person would almost certainly choose a different value. This is an aberration of both science and engineering. Most parameters, such as the speed of a light, for example, will have the same value no matter who measures it and with whatever instruments it is measured. Perhaps we might define 100% as a value not to be exceeded, such as when we reach a limit of force or power or component strength. Sometimes there is an embedded hidden safety factor. Many of you will have heard the definition of assume, which also applies equally well to presume. That is, something that will make an ass out of you and me. In most cases, 100% on a machine is simply a rounding down of previous units. Perhaps a couple of examples might illustrate this. Suppose that a bearing has limits of 123 newtons per meter for the widest machine. It is possible that the machine builder rounded it down to 100%, corresponding to 100 newtons per meter, for both calibration simplicity and to be extra conservative. You could use that extra capacity if you knew it existed. Another example is that if you have a narrower machine, you often have a lot of unused capacity because the machine was built for larger forces of the widest machine in that series. You could use that extra capacity if you knew it existed. Finally, you could push slightly harder if you're willing to live with a component having a slightly shorter life, such as a bearing motor or other component. This comes at a cost because you may need to monitor that component for condition more frequently than you would otherwise. You can use that extra capacity if you knew it existed. To get more out of your machine, you must do three things. The first is to study the PLC or computer software where those limits are coded. Second, you must study the mechanical ratings of the components. Finally, you should call the most senior designer at the builder and ask them quite pointedly and directly how you can get to 110%. They may or may not tell you or even know, but it's worth a try. I have solved many problems merely by changing a line of PLC code to remove an arbitrary control limit. You can too. Thank you so very much for letting me share stories from the field. Stay tuned for next week when we will show how to nearly eliminate operator turnover. If you have a topic you would like to hear about, let me know in the comment section below. If you found any of these stories to be interesting or useful, please like and share and subscribe. And remember to check out the show notes for surprises. See you next time.